Okay, so normal distribution. So normal distribution is continuous random variable as well. Okay, so continuous distribution. So we have two chapters, chapter 13 and 14 on discrete. So on discrete, we learn two things. One is like the table or a graph or like a mass function to represent for some particular values. Or we have the binomial distribution is discrete as well. And in continuous one, chapter 15 is on continuous. It's just talk about some hybrid function. So from 2 to 4 and anywhere else is 0. And we learn how to find the mean, median, mode, variance, standard deviation. And we also trying to calculate x greater than something, larger than something, which is talking about the area under the curve. Okay, talking about the area under the curve. So now we will like that's all general ones, okay? Because for different function you have different domains which can make area become 1. But for this one, it's a special continuous random variable, just like the binomial distribution. It's discrete distribution, but it's a special one. Okay, it has own formula for mean, median, standard deviation, like can be calculated by a different formula. This one is special as well. It's called normal distribution. Why is a special one? Okay, let's just talk about the feature for this one. So the random variable x is normally distributed. So if you ask me, for binomial, it needs to decide whether this is a binomial distribution or not, well, by looking at the question. For normal distribution, it will be very straightforward, telling you that will be a normal distribution. Okay, it's given already. So in the question, it's telling you this is a normal distribution. You don't need to guess. Okay, if you didn't see the normal, it's not a normal distribution. And we will write, okay, remember like binomial distribution, we write x is binomially distributed by two parameters. One is the n, one is the p. Okay, say x is a discrete random variable binomially distributed for number of trials is n and successful rate is p. And then we calculate the expected value by expected x equals to n times p. So that's a distribution. So similarly, we have normal distribution. We will have that notation as well. So x is normally distributed. The n is normally distributed by two parameters as well. But what are those two parameters? It's very interesting. Mu. What is mu? Expected value. Okay, so distributed by mu and standard deviation squared. That is just variance. Well, you better write in the way that is standard deviation squared, because you can both see the standard deviation and the variance. So the two things decide the distribution is mu and the standard deviation, or say the variance, which is quite interesting because it directly given that in the question. Okay, they will tell you what is the mu, what is the standard deviation, and you know this is normally distributed by what two parameters. You can see a question later. So where the probability density function for x, you know, like you have probability density function fx, right? For example, a quarter x plus 2 squared for 0 to 4, and then anywhere else is 0. This one is not a hybrid function anymore. This one is just, not that one, is just a whole distribution for domain of R. Okay, your domain will be R now. You can take negative infinity, you can take positive infinity. The whole thing under the curve is 1. The whole area under the curve is 1. So that's the function. You better remember this function. Okay, you better remember this function. Because when you do, what I can say, when you do the transformation question, that will be much easier if you can see this, you can remember that. So this one, so 1 over sigma is the standard deviation. 1 divided by standard deviation times square root 2 pi times exponential negative a half bracket x minus mu, so it's x minus the standard deviation divided by variance, and you square that. That will be the function. Okay, that will be a function. So if you have x is normally distributed by 0 and 1 squared, this notation means your x is a normal distribution. Mean is 0. Standard deviation is 1. Okay, what's the density function will look like? The density function will look like 1 over sigma is 1, so is 1 on 2 pi. Exponential negative a half. X minus 0 divided by 1, so it's still x, so it's x squared. Okay, that's the simplest equation we can have for normal distribution. That's when the mean is 0, standard deviation is 1. Okay, mean 0, standard deviation is 1. You will have that density function. You just sub sigma equals to 1 and mu equals to 0 into that function. Okay, into that function. And you will have that one. That's the simplest form for that. Alright. And doesn't matter what is the sigma, what is the mu. Your curve always looks like that. Okay, your curve always looks like that. Okay, that is the shape of your graph. Well, it can extend longer over that side and over that side. But that's the asymptotes. On the x-axis, that's the asymptotes. It never touch, never cross the x-axis. It's all above the x-axis, and the whole area under the curve is always 1. If you don't believe me, you can put that into the cast and try to integral from negative infinity to positive infinity, and you can see the area is actually 1 under the curve. Okay, it doesn't matter what you take for mu and mean. Okay, for mu and standard deviation. All right, let's have a look at the property. Well, let's do another thing. Have a look. This value and this value. Okay, so when the x equals to the mean, that will give you the highest value. The highest value is 1 on sigma square root 2 pi. Why is like that? Because remember, fx equals to 1 over sigma square root 2 pi e minus half x minus mu divided by standard deviation squared. So if x equals to mu, I will sub x equals to mu into the function. What I will have is negative a half 0 squared, because x equals to mu. Mu minus mu equals to 0. So that's a 0. Exponential to the power of 0, that is just a 1. Okay, the whole thing here equals to a 1. So f mu just equals to 1 over square root, 1 over sigma square root 2 pi. So when x equals to mu, the highest point is just the coefficient you times in front of the exponential. Okay, that gives you the highest value. So another interesting point here is mu is mean, mode, and median. Mean, mode, and median. Because this curve is symmetrical. Okay, this curve is always symmetrical. 50%, 50%. Middle, which is mu, is the highest point. Okay, it's the highest point, right? It's the highest point, and that is just highest point, mode. And I was telling you that mu is the mean, and is 3 things all at 1 value. Okay, 3 things all at 1 value. This is the special thing about the normal distribution. Okay, in normal distribution, mean, mode, and median is the same thing. And those 3 things is given already in the question. Because we write, okay, this is normally distributed by mu and standard deviation. And mu is given already. So you know what is mean, mode, and median already. And you know the standard deviation as well. Okay, standard deviation as well. And you know what is the variance. So the 5 things is actually all given in the question. In normal distribution, it's a little bit different. We are not really talking about those 5 things anymore, because those 5 things is given already. Okay, there's no point we still talking about that. So we'll calculate something else. Okay, we'll calculate something else. But we'll up to that point later. Let's have a look at the properties for this distribution. So the property is the turning point, the maximum turning point is at mu comma 1 over sigma square root 2 pi. Remember that, okay, remember that we need to use that later. Second one is the mean, median, and mode of normal distribution are the same, which is mu. Okay, as I explained, all the three things are at the same point. The 3 is the graph is symmetrical about x equals to mu. So it's symmetrical about that line. Okay, 50%, 50%. That line is x equals to mu. Okay, many of the frequencies are situated near the mean. So what that sentence means, like near the mean, you have more probabilities. So for example, from that point to that point, you have a lot of area under the curve. But if you're talking about from here to here, that's far away from the mu, you have very little probabilities there. If you're moving even further to the left to negative infinity, you have approaching to 0 probability. The area is very, very little. So the closer, like, we'll talk about that later, because when you talk about 2 standard deviation, it's about 95 of the probability. Remember that? Mean go 2 standard deviation each side, and that cover that 95 of the probability. So it's about 95 already near the mean. So if you go further, like 3 standard deviation, 4 standard deviation, like even far away from that, you almost have 0.00% of something. So it's really little probabilities after 2 standard deviation, or say 3 standard deviation. So next one is the graph extends infinitely to the right and left of the mean, but never touches or go below x-axis. It can't go below x-axis. If you go below x-axis, it's not the density function anymore. So it must stay above the x-axis. So the x-axis is actually an asymptote. Okay, it's an asymptote. It's go approaching but never touching. So as I explained, for a normal distribution, x normally distributed by mu and standard deviation squared, you have mean, mode, median is mu. Variance is standard deviation squared, and standard deviation is just sigma. It's all given. Okay, all of that is given in that. The 2 parameters is mu and standard deviation. Okay, we have another thing. This is called standard normal distribution. So what is a standard normal distribution? So it's a normal distribution as well, but it's the standard one. We normally use the random variable z. Okay, we use z to represent that's a standard normal distribution. We are not using x, we're using z to represent a standard normal distribution. When you see the letter z, you think about, oh, maybe that's a standard normal distribution. So what is a standard normal distribution? Is with mu equals to 0 and sigma equals to 1. Mu equals to 0 and sigma equals to 1. That is a standard normal distribution. So with mean 0 and standard deviation 1, that's called a standard normal distribution. So we use that a lot. Okay, we use that a lot for next session. But like we must remember what's the standard normal. With mu 0 and standard deviation 1. So what we have here is, I will just sketch a standard normal distribution here. Okay, I'll just sketch that one. So have a think. This point is 0, right? This is 0 because it's symmetrical. That's mu. What's the value here? What's the highest point? What's the highest point? What's the y value of the highest point? 1 over root 2 pi. Okay, 1 over root 2 pi. Remember, the turning point exists at that point. That's why I'm asking you to remember that. Mu and 1 over sigma square root 2 pi. Now your sigma is 1. Okay, it's just 1 over root 2 pi. So just 1 over root 2 pi. Sigma is 1. So that's 1 over root 2 pi. So to the left of 0, that's 50%. To the right of 0, that's 50%. Like, well, we can't talk about more about that now, but like we'll talk about more next lesson. And just have a think about the shape of the graph. How mu and standard deviation will control the shape of the graph. Okay, different mu and sigma will give you different shape of the graph. Have a think. The perimeter mu and sigma have an effect on the normal distribution curve. what like is talking about here? Mu controls the position of the curve. Okay, like, well, I would say the position is the middle. Where's the middle of the curve? Okay, control the position. Well, I would say that's the middle of the curve. So mu is the middle. So different mu will give you different middle. Okay, different mu will give you different middle. And the second one says standard deviation control the width or stiffness or the height of the curve. Well, I prefer the way that the height of the curve, because you know what the height of the curve will be. Okay, you know what the height of the curve will be. The height will be occur at x equals to mu and 1 over sigma root 2 pi. Like, my question here is, if I have a larger sigma, do I have a higher graph or a lower graph? If my sigma is higher, do I have a lower upper graph? Lower, because sigma is bigger. 1 over a bigger number, you have a lower graph. And also you can think about sigma is the standard deviation. It's talking about the spread of the data, like the spread of the values. It's get more spread. Your curve is actually stretching that way. It will get lower as well. So you can think about that both ways. But like, I prefer to think about that using formulas. It's much easier and clearer for me to see it. So sigma is higher, denominator is larger. 1 over a larger denominator definitely have a lower value. So when you see two graphs, you compare two graphs, just see the y value. Doesn't matter where is the x value, where is the mu. Okay, doesn't matter where is the mu. Just see the absolute height. Okay, the higher one will get a smaller standard deviation. Okay, the higher one will get a smaller standard deviation. And see the middle. Okay, if the middle exists on the right, so it will have a higher mu. Okay, we'll get a higher mu. Well, just have a look at this question here. You have mu1 and mu2. Okay, you have mu1 and mu2. So mu1 is definitely smaller than mu2. We can see that the mu2 is definitely higher. And they have the same height. So sigma are the same. Sigma are the same. So the standard deviation are the same. So they have the same height. Okay, they have the same height. So sigma is the same. And for this one, mu are the same. Mu are the same. But sigma 2 is lower. Sigma 2 is lower. So sigma 2 is greater than sigma 1. So the higher graph get the lower standard deviation. Higher graph get the lower standard deviation. So sigma 1 is actually smaller than sigma 2. Okay, that's how mu and standard deviation control the shape of the graph. Well, if you have a question, well, if I give you a quick question here, well, we can use some space below here. So we have two normal standard deviation. So I'll say x1 is normally distributed by 3 and 2 squared. And x2 is also normally distributed by -4, half squared. Okay, now I want to, on the same set of x-axis, I want to sketch both graphs. Okay, roughly. Just keep all the key features. Okay, on same set of x-axis, I want to sketch both functions here. So what I can see here is one graph is symmetrical about 3, one graph is symmetrical about -4. This standard deviation is 2, the next standard deviation is half. Okay, 3 is here, -4 is here. Okay, which graph will get a higher one? Higher graph. Which graph is higher? First one or second one? x1 or x2? Second, x2 will get a higher graph because half is smaller than 2. So we will have a graph. Well, that's not a symmetrical graph. Okay, this one will look like that. And this one. Okay, we'll definitely get a lower one. Well, if you can extend, you can extend more to that side. Well, it's not so hard to sketch. Okay, extend more to that side. So roughly the shape of the graph will look like that. Okay, -4 with a smaller mean, moving to the left. 3 had a higher one, it's moving to the right. The lower the standard deviation, the higher the graph. So half will get a higher graph, which is the blue one. And the 3 will get a lower graph, which is just like that. Well, it's not accurate, but roughly the graph will look like that. You will not be asked like sketch it accurately. You just ask like sketch normally, or give you 2 graphs, discuss the relationship between the standard deviation and the mu. Okay, the mean and the standard deviation. So talk about that. So if you give a graph like that, you say the blue graph has a smaller mean, but it has a higher standard deviation compared to the red one. Okay, so I'll just start my normal distribution here. Next week we'll start from the transformation and talk about more about the standardizing. I'll just give you a rough idea on what is normal distribution, and we can continue with that next week.